Good evening, everyone. My name is Chamudya. I'm a senior software engineer at Cisco Labs. Welcome to the third edition of PerfUp. This session focuses on the role of tech operations in performance engineering. PerfUp is powered by Cisco Labs, and today we have two speakers, each taking on a different aspect of tech operations in performance engineering. Before we get into this today's session, I would like to give you a bit of an introduction to what PerfUp is about. PerfUp is an initiative bringing together the best minds in the software engineering arena to share knowledge on latest trends and discuss best practices in the field. Each PerfUp event will feature a panel of expert speakers who will speak on their knowledge and experience in the area to inspire individuals to tackle performance engineering. Introducing your speakers for tonight, we have Madhura Sonnadara. Madhura is the Director, Infrastructure and Operations at PSN Lanka. He is an expert in infrastructure management with over 20 plus years of experience. He is on his sixth year at PSN Lanka and previously played the role of Principal Architect Infrastructure. His areas of interest include performance tuning, troubleshooting, and security. Next, we have Nirmal Kumar Siri. Nirmal is the Director Operations at Cisco Labs. Nirmal has over 15 years of experience in the IT industry, working across multiple disciplines and roles. Both as a system engineer and a leader, Nirmal has been involved with setting up new global operations engineering teams throughout his career. So that is our lineup for today. Let us get right into the session. Nirmal, over to you.
Thank you, Chamodya, for those kind introductions. Before we actually get into the topic at hand on performance engineering, Faba, is it possible for you to go back to the starting slide, the slide with the tagline? Here we go. So something that caught my eye, which I thought I'll share with you guys. The tagline for PerfUp for this particular forum goes as "Synergy to power the future of performance engineering." I believe this word synergy, I think, is a beautiful concept and a really important part of human evolution, in my opinion. The definition of synergy, I mean, if you just Google it as to what synergy means, you come up with a particular definition, right? Papa, can you go to the third slide, please? It talks about two or more components, in terms of interaction and cooperation between two or more components, entities, where the combined effect, or the which produces a combined effect which is greater than the sum of the separate effects. I believe, in my personal view, this is one of the most important aspects that has propelled the human civilization to where it is right now, the most dominant species on this planet, right? Because nobody can do things on their own individually. We need collaboration, we need coordination across different disciplines, across different teams, to be able to do the things that we do as a human civilization now. A good example is the James Webb Telescope. I'm sure most of you who are here would be aware of it. Now we have gone from the traditional telescope, which was invented maybe about 400 years ago in the 1600s. From there, within a few human generations, we are able to now produce something like the James Webb Telescope, placed maybe 500,000 miles, away from Earth, and the ability to, take pictures of some of the earliest stars, for example, right? So from that to here, to be able to do that, you have to have teams collaborating across different disciplines, different areas, even countries, I would say, to be able to produce something like that. So in that effect, I want to thank the PerfUp forum organizers for realizing the importance of different areas of performance engineering. And that's where I'm coming from a technical operations background, right? Papa, if you could go to the next slide. Now, just to give you a bit of background, I mean, I have been in the IT industry for about 18 years and primarily working across technical operations, where I've had the opportunity to set up, teams from scratch. I've seen these technical operations teams evolve from their traditional role of technical support primarily to become an integral part of performance engineering in their respective organizations. I've seen individuals starting off and going into performance engineering from technical operations and becoming later down the line in their career, performance architects, for example, because the technical operations folks bring in a unique set of skills, unique set of perspective, in my opinion, when it comes to performance engineering or performance in general of the applications or platforms that they're involved with. So that's why I'm passionate about talking about this particular subject, and theme, underlying theme that I want to highlight up front is the collaboration that needs to happen. If you are serious about, as an organization, as an individual, as a developer, as a QE, or whoever you are, if you are keen on achieving performance excellence in your applications, collaboration, bringing in all these different disciplines, including technical operations, into the picture, I think is one of the key aspects of your success as a performance, if you're search for performance excellence, right? Let's move on in that context to our next topic. Now, this particular statement, I mean, it's not from anybody else, it's just from me. I want to highlight that, it's not, traditional aspects of performance engineering that we should be focusing on. Because usually what happens is, I've seen my own experience, organizations, companies, or software engineering companies focus on the traditional aspects of, latency, throughput, to bandwidth, to whatever other, matrices that they are interested in terms of their performance engineering strategy. But one key area that they usually leave out, or they are more reactive when it comes to performance engineering, is the operations aspects of applications. Because performance engineering, in my opinion, should be a holistic view. It should not just focus on a narrow set of performance indicators or performance for the application. It should look at it from a holistic point of view. And usually the operations aspects of performance kind of gets neglected. It becomes more reactive. I've seen many occasions where when you have an issue in performance, only you realize, hey, we should introduce these stats or these error messages or these, monitoring capabilities or these, ability to troubleshoot faster into the picture, rather than thinking of it at a design and, development stage. So that, I think, it's a very important aspect that needs to be focused on for various reasons. Let's focus on some of those reasons. Paba, if you can go to the next slide. Here, some of these things are very obvious, right? I mean, naturally, the modern tech stacks, in my opinion, have become more and more complex, right? Now you have systems running upon systems upon systems. You're, pretty much integrated. Your applications or platforms can't function on their own. You obviously, rely on cloud computing technologies, containerization, infrastructure as code, or whatever other these new developments, in my opinion, adds another layer of complexity when it comes to performance engineering. So that's why, it's important, some of these operations aspects, ability to troubleshoot, for example, across these multiple systems, multiple integrations and whatnot, becomes more important. And also, as you add this complexity, if you go to the next point, Paba, it adds another layer of, individuals. You have to collaborate across, multiple teams. Especially, if you have a performance issue in production or whatever, I've noticed in many occasions where you can't do things on your own. You have to bring in your infrastructure specialist. You need to bring in your vendors. You need to bring in, various other parties that needs to collaborate across the board, which adds to the complexity of troubleshooting and which adds to the complexity of resolution of issues. And also, we live in a world where performance is becoming more and more prominent, right? I mean, we don't want to wait, in terms of our activities. We want immediate actions, and our patience, level of patience from end user point of view, is going down. So naturally, if you have issues or performance issues in your applications, the ability to respond, the time that is available to respond without a business impact becomes shorter and shorter. And of course, the other part of it is business operational hours are getting extended. And you and I would probably know. I mean, if you take an e-commerce application or whatnot, it's pretty much expected that is available 24/7. And more traditional applications, they have to function during weekends and whatnot. So extended hours of operations add to the complexity, in my opinion, of why we need to focus on the performance engineering part when it comes to operations. And last, of course, are the security concerns. Now, as you guys are aware, we are living in a new Cold War to start off with, right? I mean, with this whole situation that is happening in Ukraine, opens up another front for cyber warfare and whatnot. So security becomes even more important when it comes to performance of your applications, especially if you have to recover from major catastrophes and whatnot, right? To share an experience with you now, I have seen my fair share of code reds, major issues in my career over the years. And one of the situations that happened a few years back comes to my mind. I was having a drink. I mean, this was after hours, after office. Having a drink, with my friends, and I get a call from my infrastructure manager, and he says, all the infrastructure, critical infrastructure, is gone. I remember, becoming instantly sober. My, whatever alcohol effects have just passed on, because that's the worst case kind of scenario for an operations, person like me, right? Where the reasons why, how it happened is not important to our discussion. But the point is, there can always be problems, whether it's infrastructure, whether it's networks, or whether it's applications itself. There can always be some critical situation that can happen. Now, in this situation, of course, the application was able to function because from a performance engineering point of view, the engineering teams have thought about such situations where the backend infrastructure might not be available, and the application was able to function in offline mode. Of course, with limited functionality, but the key functionalities were working perfectly, and they were able to restore some of these key functions within about 2 hours time. The point that I'm trying to make is, given that applications demand more and more availability and ability to recover from problems, the thought given at upfront in terms of how your applications can perform even in the worst kind of situations, and how they can recover fast, how you can troubleshoot issues faster, gives you an edge. In this situation, if this particular issue happened and continued, the company would have even gone out of business, because if it's a catastrophic failure for mission critical systems, people, the end users, are not going to be patient enough, right? So at the end of the day, we were able to recover. But at the same time, that shows the importance of thinking about performance engineering holistically, not just the traditional matrices, but thinking of it from a holistic point of view, where you even consider how you can recover, troubleshoot, and so on. So here, what I want to suggest is that your applications from a performance engineering point of view should think about how effectively and efficiently you can troubleshoot and recover. And that should be a consideration upfront when you're talking about your performance engineering scope. That should not be neglected. That should be actively looked at, because more and more systems are becoming more critical, more end user dependent. So because of that, it's important to be able to recover fast. So that's one aspect of operations which I want to highlight. The other side of the coin, when it comes to technical operations, is that there are three key paradigm shifts that are happening or happened over the years in technical operations from my point of view. One of the key most important ones is that the focus on more proactive and leading to more preventive or predictive or preventive kind of operations. The world, obviously, reactive support is important, because I mean, no application is immune to bugs, for example, or other dependencies that they have. Usually there'll always be need for reactive support kind of work, in my opinion. So that's an important aspect of technical operations. But at the same time, there's a shift towards making them more proactive. How do you detect problems more proactively and address them without having a business impact? Then beyond that, how do you become more predictive and preventive in terms of understanding problems that can potentially happen, and how do you take preventive measures against it? So this is an important paradigm shift in the technical operations sphere, which I believe has a direct impact to performance engineering as well. Then the second shift, I believe, there's one important aspect that again has an impact on performance engineering, is the shift from the traditional technical operations to more site reliability engineering. Site reliability engineering talks about looking at both engineering and operations holistically, where the technical operations people are more capable in terms of both infrastructure, in terms of performance engineering, in terms of getting involved in technical testing, involved in automation, and better workarounds and so on. So building more capabilities in the operations layer through concepts such as site reliability engineering is a new paradigm shift that is definitely taking shape in our sphere. And then the last one, of course, is the importance of first contact resolutions. When you have an issue, how fast you can respond to such issues. Does it require going through multiple layers of escalations and then ultimately getting a resolution, versus whether you can escalate it, then there a solution can be given to the problem. So these are some of the three key aspects of paradigm shifts that are happening across the technical operations sphere, in my opinion, that are important to our discussion on performance engineering. Let's focus on the first one, the move to more proactive and predictive kind of operations. Here, I believe performance engineering at a very early stage has a major role to play in terms of how you detect problems, how you are able to proactively or predictively understand your applications problems that can come up, right? Because all applications have their limitations. I mean, no matter how much you invest on to auto scaling to whatnot, there'll always be certain limitations of performance on your applications. So how you are able to detect anomalies, how you are able to identify the stats and indices that are needed to troubleshoot, for example, are very important considerations from a performance engineering point of view at a very early stage, in my opinion. The reason why I say that is that, in my experience, sometimes we are reactive. Only when we have a production issue that we realize, hey, we need an error message here, or we need a particular stat that we need to be able to figure out what's going on in the application. So sometimes it's reactive. But I believe if we are serious about looking at performance engineering holistically, looking at effective detection of problems and effective error messages and information that is needed is a key aspect of consideration that should be done at performance engineering level. And also, there are lots of tools and capabilities that are out there that gives organizations the ability to effectively detect and resolve problems in that context. Now at Cisco Labs, for example, we are starting to roll out Datadog. I'm sure some of you would have heard about this particular tool. In my opinion, it's a beautiful tool that gives you a lot of capabilities to kind of at a both infrastructure and application level to be able to identify anomalies and errors that are taking shape, right? And not only just the detection tool of it. I believe the next stages of that detection, that is in terms of proper escalation, proper accountability, and being able to track the trends over a period of time, also very important when it comes to performance engineering of your applications. Because now let's say in our context at Cisco Labs, for example, we use Datadog to detect certain problems both at infrastructure and application level, and then we have integrated that with ServiceNow, which gives you another additional layer of smartness, where you can kind of create accountability. You can create tickets based automatically based on the alerts, and then that is integrated with the medium of escalation. That is, we use, for example, a tool called Xmatters, where it gives you beautiful capability to make the escalations right depending on the severity or priority or whatever you call it. It will make the relevant escalations to the relevant people. So in a way, this whole process kind of is linked up, right? Now you have the detection happening automatically, you have the smartness or the accountability coming in through something like ServiceNow, and then you have the escalation automatically happening to the right parties saying there's an anomaly, there's a problem going on. So the point that I'm trying to make here is that from performance engineering point of view, your ability to understand what's going on in the application or the platform, your ability to detect anomalies or problematic situations, your ability to create accountability and escalate it to the right people on a timely and effective and efficient basis is a very important aspect that should be considered in performance engineering, in my opinion, because it gives you that edge over being able to react to problems that might be happening in your applications and resolve them on a proactive or predictive basis. This gives rise to a new concept called AI Ops. I'm sure some of you would have heard this term, where data analytics and machine learning can also be plugged in, where you can easily see certain trends, certain certain limitations, and being able to take smart decisions upfront rather than waiting something until something goes wrong. So that's one, I think, up and coming concept which is important to performance engineering from an AI Ops point of view. Right, moving on. Papa, if you can go to the next slide. Here, I want to again focus on the modern, we talked about this paradigm shift towards building more capability at the operations layer, or building more capability with engineering to be able to look at operations as well. The whole rise of the prominence of site reliability engineering. this particular concept that I'm trying to highlight here, the right shift or the shift right, concept, is also in line with that particular development where people are more capable at the operations level, operations layer, and maybe become an integral part of the performance engineering apparatus of your organization. Now you might ask, hey, performance engineering talks about the left shift mostly. Performance engineering as a concept talks about doing performance engineering at a very granular level, right? I mean, the whole idea of prominence of performance engineering starts with the requirements gathering itself and design stage and so on and so forth. It talks about the importance of doing performance engineering at an individual component level and doing that at a very early stage rather than doing it later once things hit production or whatever. That's the left shift part of it. So then what am I talking about? A right shift. Here I'm talking about not ignoring left shift and moving to the right shift. I'm talking about you have to do your left shift. You have to obviously focus on performance engineering at a very early stage at a component and a granular level. But at the same time, you can't ignore the right shift, the right side of the equation as well. Here, I'm talking about the fact that certain situations when it comes to performance holistically, when you look at your applications, you can't maybe simulate some of that at a granular level. The reason why I say that again leads back to my previous argument, because applications are becoming more and more complex, where you are running upon systems and you are lot of the time you are integrated with a lot of other other systems, third parties that you have to work with. So in such situations you can't effectively test the entire application and how it's supposed to perform from an end user point of view, how it's supposed to perform under stress and various conditions, how it's supposed to perform in failure recovery scenarios, maybe at a granular level in the left side of your equation. You need to obviously focus on the right side of the equation as well, that is doing performance engineering from a holistic point of view, where you might do these things at a production simulated kind of a situation where you are able to replicate situations that happens in a production environment more effectively, more accurately, and do it in a way that you look at it from a holistic point of view rather than just focusing on a narrow set of components. And in most cases, this is not a new trend, but this has been happening throughout the years now. For example, even before software engineering came into picture, when they used to, let's say shipbuilding, before they actually, commercial ship that goes out into the sea, they do something called sea trials, where the ship has to go through simulated kind of, they put this, ship into the sea and they do trials with it. And only if they pass through those trials, the ship is commissioned to be able to serve or carry goods or people or whatever. So the same concept applies to software engineering or development, in my opinion, as well, where production situations and simulating environments sometimes go to the level of doing testing on your production environment itself. So that's one aspect of it. There are certain companies like, for example, Netflix and all, they're increasingly doing testing at the production stage itself, simply because they can't replicate some of those other situations that can come up, the integrations that are needed and whatnot in a simulated environment. And also it talks about taking insights from production itself. So your performance engineering strategy should definitely look into what your production systems are going through and ability to take insights from that to create your performance engineering strategy and concepts and the scope. I think that's a very important aspect, because in my experience in technical operations, sometimes the issues that come up are things that are so trivial at times that you tend to ignore them, or these are complex in such way that you can't simulate it at a very granular level. So because of that you have not done that in a production kind of a setup. So again, the bottom line here is that you can't ignore the left side of the equation. Naturally, you need to focus your performance engineering strategy at a very granular level, but at the same time you should not ignore the right side, the production side, the actual systems working together side of the equation, and making sure that that is also a part of your performance engineering strategy. So that leads to the evolution of something called test ops. Now this is something that as a manager, as a director, I have promoted quite often, to rope in the technical operations teams into your testing apparatus, because traditionally this has been the domain of QE engineers. But in my opinion, by roping in the technical operations teams also as a part of your performance or test ops kind of strategy, it gives you both sides of the equation. It gives you like a win-win situation where one side, you get the perspective of operations people. They might bring in their unique set of skills, their ability to understand the production systems, the production business end user requirements and whatnot, and bring in that perspective to your performance capable testing capabilities. And the other side of the equation is that it's a great learning opportunity. It gives the ability for the technical support people or operations people to understand the system in and out, be able to respond to situations much faster, be able to troubleshoot, and to understand what's going on in your systems in the first place, to be able to resolve them. So again, in my opinion, bringing in your technical operations capabilities into the fold of performance engineering, into the fold of performance testing, I believe is a win-win across the board, because that collaboration will lead to better results across the board. With that, I want to conclude and highlighting the two key aspects which I wanted to talk about in this particular forum. One is the holistic approach. You should not look at performance engineering just from the traditional matrices of performance, but include operations also into the fold, into your performance engineering strategy and scope. And the second part of it is the right shift, where you bring in your technical operations capabilities, teams and individuals to be a part of the performance engineering strategy, enable them, collaborate with them, bring in that synergy across the board. So that's what I want to leave you with. With that, I will hand it off to Chamodya and to Madhura to carry on.
Thank you, Nirmal. Thank you for valuable insights. Quick reminder, you can just post your questions with the link on the chat. And next we have Madhura. Madhura, over to you.
Okay, thanks, Samuddin. Good evening, everyone. So, performance engineering actually, like Nirmal said, it's actually a cultural shift in the way organizations view their kind of essential processes, right? So, with my experience, I've been in the IT industry for 20 plus years now. And currently, I'm a director for infrastructure and operations at PSN Blanca. We've seen like so many performance-related problems in my career, and it has been quite complex to resolve as well. So, if you look at performance engineering, it embraces practices and capabilities that build quality and performance throughout, right? And this actually enables organizations to increase the revenue, the customer interaction, retention, and the brand value as well. And you get the competitive advantage as well. And the focus is actually meeting and exceeding the expectations of of your customers. Can we move to the next slide, please? Okay, so here I would like to kind of highlight some of the stats to kind of highlight why performance is quite significant in today's world. So as Nirmal also pointed out, this the online folks, the shoppers, and who uses the systems are very, very impatient, because we have been actually using platforms like Google, Amazon and very mature platforms which perform really well, right? So according to Aberdeen research, the average online shopper expects a page load time of 2 seconds or less. And what happens afterwards? Just after 3 seconds, 40% abandon your page. And out of that 40, 80 will not return again, right? So that's significant how performance contributes to your the revenue, I would say. And a slow or a broken site will impact revenue significantly, which means, like, say, for example, if you consider the impact of a 1 second delay, right? There can be 7% loss in conversions, which means, like, if it's a e-commerce site, the time you kind of log into the system to say click on buy, or go to the shopping cart, right? So that's a conversion. So you will lose about 7% of your conversions due to a 1 second delay. And 60% decrease in customer satisfaction, right? And again, a 1 second delay could cause 11% decline in page views, right? So if you look at e-commerce site, which generates about $5,000 per day, this 1 second delay has been calculated to kind of a revenue loss of around 127,750 per year. So if you look at the performance statistics, it really matters that you have a very performant and good, efficient system that caters to our customer requirements, right? Okay, can we go to the next slide, please? Okay, and some of the things that one of the things that come up when we discuss about performance engineering is the difference between performance testing and engineering. So testing, of course, is just a quality check, and it's to check whether we can handle the load and the responsiveness. Whereas performance engineering is actually, like Nirmal said, it's much more holistic, and it looks at the end-to-end tuned and efficient systems. And performance testing is done post-development, whereas performance engineering is a continual process that happens throughout the software development life cycle. And if you look at the knowledge requirements, so performance testing is actually looking at the testing concepts, and you use the tools like load runner and other performance testing tools, and it involves results analysis. Whereas performance engineering is very holistic, right? It needs application design level knowledge, then the architectural knowledge, development, then you need to know about the tuning aspects of things, then the performance optimization, and you need to kind of look at bottlenecks and root cause analysis and corrective measures, and the monitoring side as well. And so performance testing looks at performance issues, whereas performance engineering is a holistic approach, and the issues that you find in performance testing, you need to kind of find the root causes and fix these issues from a performance engineering aspect. So, and again, testing actually, we look at the NFRs, non-functional requirements, and look at the baselines, and you kind of identify bottlenecks, whereas performance engineering focuses on the overall performance of things. And if you look at who actually performs this, performance testing is conducted by the QA teams, whereas performance engineering is a holistic approach, and it involves multiple parties. Shall we move on to the next slide? So if you look at the need of performance engineering, so one of the things is that we need to be able to retain the customer and attract the customers, right? So customer attraction and retention due to a better experience is one of the key areas in performance engineering. And since we look at things holistically, like Nirmal said, we look at the resilience side of things as well, right? So when we design systems, we want those systems to be fault tolerant, be able to take up the high loads, consumer loads that are thrown at it. So increased uptime is one of the outcomes of performance engineering. And also, I've seen very complex issues that once they creep into production, they've taken lots of effort, like we had to do multiple cycles of performance testing and look at performance matrices very closely, and look at various other stats to identify and rectify, which involves a lot of folks, and also it involves a lot of effort as well, time and money. So it'll avoid and reduce the rework and the refactoring of efforts as well. And And the other part is like once a performance engineered system, it'll work with very good harmony. Like so, what Nirmal also pointed out, the current systems are very, very complex these days. We have so many integrations. For example, some of our applications like having multiple integrations, and when there is a performance degradation, it's very hard to find out where it actually occurs, right? So the pinpointing is very, very difficult. So with this effort, we get highly efficient systems working with very good harmony with each other. And the other thing is usually we always over provision our environments, right? So be it in the cloud or in the data center, especially in the data center, there is a risk if you don't over provision as well. So we tend to over provision our infrastructure. But with proper performance engineering practices, what we do is we kind of look at the required footprint, right? So we can reduce the infrastructure footprint significantly with these efforts, and overall it contributes to significant time savings because we would be catching certain issues and we would be making things optimal before it reaches to production, right? So there is significant time savings and significant cost savings due to these as well. And the, the other area is we will have the necessary insights in place, and it actually will help us troubleshoot and help us in faster recovery. And one of the main areas is that we need to look at is at end-to-end performance optimization, because like I said before, there should be perfect harmony when there are like multiple components or integrations working together to have a kind of optimal user experience holistically, I would say. Okay, so if you look at end-to-end optimizations, now this the diagram on the left-hand side, it shows simple on-prem related setup, whereas on the right-hand side, you have a cloud-related setup. So what we need to understand is, and what we need to do is, so for example, if you have an application that needs to run on a cloud infrastructure, right? So you should be able to look at the infrastructure and design that application accordingly. Otherwise, no matter what, you just go and deploy it, you won't get the optimal performance in there. The same way, if it's a data center related application, you need to understand the data center, the architecture, and what we can do to kind of make things much more optimal and performant, right? So shall we move on to the next one, please? Okay, so when you look at end-to-end optimization, so there are multiple layers, right? This is where actually that collaboration needs to happen, because from a TechOps perspective, so there are like certain areas that can be actually most of the layers can be tuned properly, right? And so in order to kind of tune them, you need to understand how the application works, right? So if you look at these different areas, say for example, at the network layer, so you have multiple areas that you can look at, starting from content delivery networks to load balancers to switches and so forth. So just by introducing a content delivery network, you can make your application perform better, because it will serve the content which is closer to the customer, right? Similarly, at load balancer levels, you have various things that you can tweak to make things performant. And on the other hand, if you don't look at these things, there can be performance related issues later on when you have like high loads. So another area is the compute side of things. So either physical or virtual, there are like optimizations that you can do so that it kind of matches your application. So at a physical level, the way you choose your hardware where you kind of look at the controllers, like the storage controllers and stuff like that, how you size it is actually critical. And even in the virtual infrastructure, you can do certain performance related configurations which will make things optimal for your application. And if you look at the storage, again, there are multiple things that you can do to make things performance. So we had some examples where we kind of did some migrations and we realized some of our workloads were like performing at high load. It was having performance degradation. So what we figured out was like there was a conflict between encryption and also deduplication, a setting which actually is interfering with the encryption. So like that, there are like multiple things that you can tweak to kind of make the overall performance better. And the other area is the security side of things. So when you introduce security devices, there's always a performance hit, right? So you need to be cognizant about it. And there are certain things that you can do to kind of minimize it. And also there, in my experience, I've seen some saturations in these devices as well, firewalls. In a particular case, there was this firewall related issue which we faced. Yeah, these are very beefy firewalls, but what ultimately was happening was the default configuration was optimal enough for the CPU cores to be kind of taking the workload in a distributed manner. So there are multiple things that can actually be done at these layers. So the other area is the application architecture, the design coding is also an area where there can be significant improvements where we could do to make things performant. And another key area is the database architecture side of things. So in my experience, I've seen many times where the database related the architecture and how things work cause a lot of performance related issues. And there are many things that you can do to kind of tune these as well. And you can definitely look at caching options. And if you do have integrations, it can be quite complex. So you need to look at the holistic view and how these integrations work with each other as well. Okay, so shall we move on to the next place? Okay, so I would like to go through one of the examples where we kind of faced in our one of the data center applications, which was actually talking to the cloud. So in this, what we did was like we did a simple change where we changed the AWS load balancer to a different one. So from a passive one, we actually moved to a application load balancer. And so with that change, we saw a lot of significant performance degradation at high load. And so this was a very complex issue that we faced. So, and we had to kind of look at it holistically and do multiple rounds of performance tests to kind of identify what was happening. And eventually, so as a workaround, we managed to kind of fix it at an infrastructure layer. So eventually, what the cost was at high load, the connections that were being generated from the data center to the cloud, to the AWS ALB, it was being saturated at high loads. So with that, there was a significant performance degradation that happens. So we have application performance monitoring monitoring solutions constantly picking up these matrices in our production environment. So once we kind of identified what the exact issue was, so the the root cause was for each request, we were kind of creating a new connection, but this was performing much better with the previous load balancer, but in the application load balancer, this was slightly different. As a result, it caused these performance saturations. So the, the fix was actually to do connection pooling. So once we did the connection pooling, if you look at the right-hand side, uh, the graph, there was a significant performance improvement. So from about 100, so these requests took about 150 milliseconds. From 150 milliseconds to it came down to half, to 75 milliseconds, right? And if you look at the ALB, load balancer, the connections which were going at around close to 5,000 immediately came to a handful, right? So, and at the bottom, you see another application that had the same problem and how it improved. So, uh, so with this, we got a very significant performance boost. And the other thing why I wanted to highlight this was that since it was a complex issue, we had to get all the lot of areas in the tech ops involved to troubleshoot this, starting from the network folks to the virtualizations to the OS guys and the developers to identify what really was happening. So it was actually quite time consuming and costly. So these are some of the things which we can, like with performance engineering, if you go into these details, we can actually in the initial phases of the software development life cycle, we can identify these and make it optimal so that things are much more performant, right? So can you move to the next one? So here, I just wanted to kind of highlight why this kind of had a significant improvement when we did this. So if you look at the TCP/IP connection establishment and the secure channel like HTTPS connection establishment. So the initial phase where the TCP connection happens, in this particular example, it has taken about 56 milliseconds. And for the TLS connection to be established, it has taken about 112 milliseconds. So by doing the connection pooling, we eliminate the entire overhead, making things much more performant. So I have seen this in many cases, and I think it's a common problem that we see. So it can be when applications talk to a different application, and also if it's a database related connection, also you can actually leverage connection pooling to get this advantage. Okay, shall we move on? Okay, so the other example is now this is a very large application that we have catering to kind of millions of learners, and these databases, the servers were also very beefy ones with around 512 GB RAMs and about 32 cores of CPU with quad-core processors. So what we saw was we had significant performance degradation at high load, right? And so we took a holistic approach where we looked at it, the entire thing end to end, and we saw where the bottleneck was. We kind of figured out where the bottleneck was and did an end-to-end tuning of the DB infrastructure, right? So with that, if you see on the right-hand side, we see the before results were like, if you look at the yellow portion of it, it represents the time it takes for the DB calls. So with all the changes that we did, so it came to a minimal level, and this became very performant. As a result, if you can go to the next slide. So as a result, we got much better customer experience, and there were like we used to experience critical incidents during very high loads. So there was a significant reduction in the critical incidents, and there was very smooth operations during peak load times as well. And there was we could see increased stability, and as a result, so when there's instability and when databases go down, there's a likelihood of data corruption. So we kind of eliminated all that, and also we reduced the storage overhead as well. And with that, the RTO times to restore the copies also was quite improved, and the backup sizes were quite manageable. So if you look at the improvements that we did, we did multiple improvements here. So from a storage connectivity perspective, the servers HP adapters were tuned. And on the block level storage, we kind of did some optimization around DDoP, and stored procedures were kind of optimized, and indexes were kind of rebuilt, and we integrated automated monitoring and healing. So what happened was, like, sometimes some of the stored procedures uh, came up with non-optimal execution plans. So we kind of had monitoring pick it up automatically, and we would kind of recompile that to avoid it. Right? And with the backup tuning, we were able to manage to bring down the 20 TB backup files to just 6 TB. So, and from a replication perspective, we did optimizations there, which actually resulted in reduced lag times for the replication. So what I wanted to highlight is that so, tech ops involvement in these kind of areas is quite critical, and we can actually add a lot of value from a performance engineering perspective, because we know the infrastructure, we know what can be tuned. It's just that we need to have that collaboration between all of us to understand how the application works, so that we can make the necessary optimizations from the infrastructure side, from a technical operations perspective. So with that, I actually we can end my session, and over to you, Shamudya.
Thank you, Madhu. Thank you very much for that informative presentation. So now it's time for the questions, and the link is on the chat. Feel free to post your questions. So we have several questions that have been posted. To start off with, the first question is, with a holistic approach, what tools have you seen integrated with Datadog as a software as the next step of escalation, that is load balancing? Let me repeat. With a holistic approach, what tools have you seen integrated with Datadog as a software for the next step of escalation, that is load balancing? Nirmal, would you like to take this on?
Sure. No, but let me start off by saying I am not a Datadog expert per se, but because it's a separate domain, it's a massive area in terms of its capabilities and integrations. So what I've seen is, for example, from integration point of view, Datadog boasts about having already built kind of integrations for like 500 plus integrations, which you can use across different capabilities. But I'm sure there are see, for example, the agent for Datadog is capable of even working across NLBs and ALBs and ELB and whatnot when it comes to, let's say, AWS. But likewise, if it's you're specifically looking for detecting issues with load balancer, Datadog has certain capabilities, built-in capabilities that can give you that integration and ability to monitor load balancing. If your question is more towards how do you do escalations, now I can talk about the setup that we have done at Cisco Labs. What we have done is we have integrated or we have the Datadog platform, which kind of detects the infrastructure application related issues through various mechanisms. It can be certain mechanisms like having the agent picking up certain stats directly from infrastructure. It can be certain alerts that the agent goes through logs and whatnot, specifically logic that we have developed to detect certain situations. Then once it detects, it is integrated with ServiceNow, which means ServiceNow, let's say for example, I've seen in many occasions where when it comes to especially performance related matrices, you have garbage alerts, right? I mean, that means, say you detect a particular issue and then the alert repeats, frequently every 5 minutes or 5 seconds or whatever, you create, issues and, incidents. That is, it's garbage, pure garbage. You can't really effectively use that kind of alerts. So that's where ServiceNow is integrated. That kind of gives another smart kind of layer where you can, program ServiceNow to certain logic, so that it detects the right situation and then creates the particular ticket or accountability in that context on ServiceNow itself. And then we have then integrated with ServiceNow, we have integrated something called X Matters, where X Matters is a piece of software which you can kind of publish your roster or the key individuals that needs to be escalated based on different severities or whatever, depending on the time. So it picks up and then identifies whether to give that person a call, whether that person should be sent a text or whatever. That medium of escalation is governed through Xmatter. So likewise, there are different solutions. What I can recommend to you, Miguel, in terms of your specific question, would be to read through Datadog. It has a lot of material with regards to integrations, specifically built-in kind of capabilities in Datadog, as well as figure out your own requirement and look for solutions, because depending on the different applications, depending on different situations, I believe there are lots of different options for integrations and escalation. I hope that answers your question.
Thank you, Nirmal. Okay, next up we have another question. For a startup or a new company, how can we initiate practicing tech ops paradigm shift? I think this is a really important question. Let me repeat. For a startup or a new company, how can we initiate practicing tech ops as a paradigm shift?
Madhura, can I take up that question? So
Yes, yes, please.
the concept behind the whole empowerment of operations, or basically the shift towards site reliability engineering rather than this traditional technical operations, reactive support or whatever that people are doing, I believe has a direct impact on startups as well, because startups, in traditional concepts, talk about small teams, right? I mean, a closely knit bunch of individuals taking a concept and developing a product or a solution around it. So in that context, in my opinion, the site reliability engineering can be even faster, and it can be implemented faster in a startup kind of an environment compared to a traditional organization which has to cover 24/7 operations and have a lot of issues that might be reactive support requests that might be coming through. Comparatively might be easier to enable the operations people develop their capabilities and to kind of in my opinion, enable them more than anything else to be able to upskill themselves as well as get involved and think of applications holistically rather than just the traditional support part of it. However, having said that, one of the main challenges of implementing this particular domain shift or tech ops kind of paradigm shift is the workload. Sometimes I've seen in even in my organization there can be small teams, 2 or 3 individuals that are specifically looking after the reactive support part of it, and they're overwhelmed by the number of requests that comes in, and because of that they can't really upskill themselves or get involved in some of the other performance engineering to testing to various other value additions that they can bring in. So it's like a vicious cycle where you're doing routine but operational critical work, and that doesn't give you enough time to kind of focus on the improvements. We need to break this cycle. As managers, as decision makers, in my opinion, you need to take small steps at it, find ways to maybe improve the reduce the reactive support workload, and that comes through again maybe investing time onto automations, investing time onto improvements across the board, so that your individuals, your teams are capable of then upskilling themselves and looking at more value additions. It's like a snowball effect, right? So you start small. My suggestion would be to start small, have that bigger horizon, in your the bigger vision of enabled site reliability engineering function in your tech ops. Have that vision, but take small steps at it so that you break the vicious cycle of reactive support and then free up people to upskill themselves and get more involved in more value adding kind of work. I have seen this happening across my own teams where let's say you do a certain automation of a workaround, reduces the workload, frees up the individuals, then they can focus on further value addition and capabilities. I hope that answered that question. But I understand it's a unique challenge simply because in startups, your resources might be limited, the access to tools and capabilities that we spoke about, like Datadog or whatever, might be limited. But at the end of the day, there are always workarounds and other ways to creative ways to maybe try and address that problem and reduce the workload of reactive support so that better value addition can be brought over through TechOps.
Thank you, Nirmal. Moving on to the next question, we have how can we differentiate QE role and ops role in the right shift? Let me repeat, how can we differentiate QE role and ops role in the right shift?
If you ask me, see, there's multiple ways to look at it. At the end of the day, QE, I mean, I'm say quality is a function of, in my opinion, quality is not just limited to QEs, right? I mean, if it comes to performance quality of application or whatever, it should not be limited to the QE function. In how I've approached, I mean, there are multiple ways to do this. There's no right or wrong way, in my opinion. But at least what I've seen work is that instead of calling them a QE team separately and say, hey, you are a, let's say you have a TechOps engineer or a site reliability engineer which you want to plug into the performance testing or test ops kind of capability, you should not rename that person and say you're a QE. Instead of kind of branding them saying you're responsible for quality or testing or whatever, you try to supplement your QE, your quality, capability through adding more capabilities through these different disciplines. So instead of branding them, if you create a cross-functional team, maybe coming together for a specific mission of performance engineering, they bring in their own expertise and capabilities. You identify what those strengths and weaknesses are, and then create a team that is inclusive of everybody. You don't have to term them as QE roles or whatever. You are giving them a mission to improve performance holistically across all aspects of performance, right? So again, it's a difficult question to answer simply because, in my opinion, they should not differentiate between these different roles. Obviously, they bring in their own strengths and weaknesses, and they should supplement each other. The QE people should give their expertise on test automation to whatever other capabilities to the TechOps people. TechOps people should bring in their operations perspective, their infrastructure knowledge, and whatnot, and amalgamate that with the knowledge the QEs possess. So if you can build that cohesive kind of unit where the people work together, I have seen brilliant results. I've seen this happen in my previous organization, Millennium IT or LSEG, where by creating these cross-functional teams, they were able to leverage best of both sides. I hope that answers your question.
Thank you, Nirmal. And the final question, does TechOps teams compare application performance after each releases, and how can we bring that information to improve pre-prod perf testing approaches? Let me quickly repeat. Does TechOps teams compare application performance after each releases, and how can we bring that information to improve pre-prod perf testing approach? Maybe Madhura, with your experience, you would be able to take this.
So on that one, we don't always perform this application performance stats, but what we do is, like, if there is a critical release which we think that certain areas of the operations like infrastructure is touched and taxed, we will look at those. But the thing is, like, from from an application performance monitoring perspective, we have New Relic APM running. So after each release, we look at the statistics and we can kind of understand how the application has been performing. So at the same time, if there's a particular problem, then we get the tech ops involved and go into we have our own dashboards to kind of look at additional advanced matrices. We look at them and find out if there are certain performance related issues or saturations which are happening in the infrastructure layer.
Thank you, Madhuri. Thank you for insights. All right, so that's all we have, and thanks everyone for being here with us and being a part of today's event. We really appreciate it. And additionally, if you have any other questions, feel free to reach out to us via Cisco Labs social media profiles or even on our meetup page, and we will try our best to answer them. And thanks again to the speakers and everyone that joined today. Have a good night and stay safe.
Thanks for the opportunity, Ramadeo.
Thank
Thank
you.
you.
Thanks for the opportunity.
Thanks.